Now here the question is, let C1 and C2 be two biased coins such that probability of getting head in a single toss are 2 by 3 and 1 by 3. So for this coin C1, suppose getting a heads, it is success. So this P1 is 2 by 3. We are defining getting a heads as success. And Q1 is 1 by 3. And for the second coin, probability of getting head, it is 1 by 3. And probability of getting a tail is 2 by 3. Now it says, suppose alpha is the number of heads that appear when C1 is tossed twice independently. And suppose beta is the number of heads that appears when C2 is tossed twice independently. So here we have two throws. And here also we have two throws. And in this case, value of alpha can be 0, 1 and 2. And here value of beta can be 0, 1 and 2. Now it says, find the probability that roots of the quadratic polynomial x square plus ax plus b are real and equal. Now roots will be equal if alpha square minus 4 beta equals 0 or alpha square equals 4 beta. Now we have two cases. Case 1, when alpha is 0 and beta is 0, and this second case when beta is 1 and alpha is 2. So these are the only two ways possible in which roots of this quadratic polynomial will be real and equal. Now for this first case, when alpha is 0, this probability will be given by 2c0 p1 to the power 0 q1 square, and for beta 2c0 p2 to the power 0 and q2 square. Now q1 square is 1 by 9 and q2 square is 4 by 9. So it will be 4 by 81. And for the second case, this probability will be 2c2 p1 square q1 to the power 0, and for beta equals 1, it will be 2c1 p2 q2. Now this is 2 into now p1 square, and p1 square is 4 by 9. Now p2 is 1 by 3 and q2 is 2 by 3. So there will be 16 by 81. So this total probability, it will be simply 20 by 81, and that's your option B.